Okay, so basis function regression. One trick you can use to adapt linear regression to nonlinear relationship between variables is to transform the data according to basis functions. We have seen one version of this before. Okay, so it's like you say you have this multidimensional linear model, a linear model which is multidimensional. I think I showed you that, right? Okay, so a0 plus a1x1 plus a2x plus a3x3 and so on. Right? Okay, and build the x1, x2, x3, and so on from our single dimensional input x. Okay, then let x n equal to fn of x. Okay, so basis function regression. We take this linear model. Okay, this is our linear model. Okay, and here I say non-linear data. We can fit this to a non-linear data as well. Okay, and this we actually transform the data. Okay, let's say data like transform or something. Okay, so what we do is we take the data, which is the input, x1, x2, x3, and then we send it through some function. You're a function model. Okay, we send it through this, and then that function will take this to another, higher dimension, a higher dimension. Okay, higher and more complex dimension. Okay, so so let me quickly show you what's okay. All right, so okay, now yeah, I think we were here yesterday. Let's see, 740. Let's see where we were at. So this one right here. So okay, we did this yesterday, right? Okay, let me quickly see what was here. Okay, so anyway, so yeah, let's I'm gonna do it right here. Right? Let's delete it. Okay. All right. Now, what this does is, so what is basis function? Right? Basis function will be here. Right? So let's try to understand that. What is basis function? Okay. Basis function. Okay. So what it does is you have, say for example, you have these inputs, right? Inputs, input. Okay. So which is a three-dimensional, right? We have x1, x2, x3. You have three-dimensional input, right? And then you want to apply, this is three-dimensional, and then you want to apply a linear regression, right? Linear regression on it, right? Of course, it's going to be multidimensional. You see, I have three-dimensional x1, x2, x3, right? Three-dimensional. When we see the linear model, linear model, our model will be like this. Okay? Our model your model would be like this. Okay? A0 plus y is equal to b. Y is equal to A0 plus A1 x1 plus A2 x2 plus A3 x3. Okay? This is a linear model because there's no power. Keep power certain, power sign. Right? Degree. It's a degree 1. It's all degree 1. Okay. So this is basically a linear model. Right? This is a linear model. Okay, good. Okay, so input a model. Say we want to fit this kind of model, this linear model, a linear model to some of these inputs. Right? X1, x2, x3. Okay. So from a single. Okay. So that is we let. Okay. So we can take this, and then what we can do is we can do we can send this data, right, this data through some kind of a function, right, some kind of function. Let's say fn, है. So हामीले के गर्छौं भन्दाखेरि let's call it x, है. Okay, this is x, right? X, which is x1, x2, x3. Right? This is a components. Right? So you send x through this, and then this function, okay, transforms this. It transforms this x and gives you, say, x. Let's say x. Let's use the same notation here. X to the power n. Right? So this function does some kind of a transformation on the input. Right? Input ma transform गरिदिन्छ कि fn ले. Right? This fn. Okay. So what it does is it transforms the input like transform. It takes it to, it does some transformation, right? Of your case means the fn of your case means polynomial, right? So we want to do polynomial regression, right? So when we see q into the idea of यसरी transform गर्दा, for example, fn of x equal to x to the power n, right? So you are like maybe okay. So this is what you're giving. And input is of course x1, x2, x3, right? So which would be like this is model to say, and the x to the power n now you'll have what? So you have something like so this thing right here, right? So you say that, right? You have this one, right? Okay. It will make it a0 plus a1 x1 squared plus make sure, yeah, okay, or rather a1 x a2. Okay, so okay, so we take the whole x, I know whole x rather, right? So we don't LIC component monolism, right? Just the vector go. Let me correct this thing. Okay, so a1 x plus a2 x squared plus a3 x cubed, right? Okay, so now what x think you about, right? We have transformed x, right? So we have transformed x means your x is, say, your x is the x1, x2, x3, right? Okay, so these are all, let's say they're vectors, right? They're vectors, right? Okay, so now if you have the component, the vector, your vectors x1, x2, x3 छ अब ट्रान्सफर्मेसन भएर के हुन्छ भन्दाखेरि अब चाहिँ के हुन्छ भन्दाखेरि अब हाम्रो यस्तो आउँछ है x1 x2 x3 अब x नै भयो यो चाहिँ दिस इज जस्ट सिम्पली x हैन अब यो चाहिँ के हुन्छ भन्दाखेरि है x1 स्क्वायर x2 स्क्वायर र x3 स्क्वायर है राइट ओके त्यसै गरी यो चाहिँ के हुन्छ x1 क्यूब x2 क्यूब र x3 क्यूब है यसरी जान्छ के सो यस्तो खालको ट्रान्सफर्मेसन हुन्छ सो that means we transform, right? We transform the input, right? We do not change the model चाहिँ जस्तो त्यस्तै रहन्छ तर we just change the input. So our input is x, right? Our input x छ भने अब यसलाई यसले चाहिँ यसले के गर्छ भन्दाखेरि यो इनपुटलाई यसले it takes it to a polynomial form, है यो चाहिँ polynomial है so यो चाहिँ polynomial हो polynomial पछि यसले चाहिँ अर्को डिग्रीमा लिन्छ हेर्नुस् त so degree 1 degree 2 degree 3 हैन भने ओभरअल यो degree 3 हुन्छ है so x1 x2 x3 x1 square plus x3 square x3 square and so on है so यसरी जान्छ हैन अनि यो जुन ट्रान्सफर्मेसन फंक्सन छ नि this function right here है so this is called the basis function यसलाई हामी के भन्छौं this is the basis function है अब यो केसमा के भन्दा it's converting that to some polynomial form है यो simple linear यसलाई चाहिँ polynomial form मा लक हुन्छ त्यसले गर्दा यो चाहिँ यो केसमा के भयो यो पर्टिकुलर केसमा चाहिँ यो polynomial basis function भयो है polynomial basis function भयो है so okay so that's what it's doing है यसले चाहिँ polynomial basis function भने के भने let me recap a little bit here है okay what does the basis function do? It takes some input, okay, input, and takes it to some other basis, some other coordinate system. Hey, ओके त्यसलाई अर्कै स्पेसमा लैजान्छ कि है हाम्रो यो स्पेसबाट है इट टेक्स इट दिस बेसिस फंक्सनले अर्को स्पेसमा पुर्याइन्छ है अर्को कोअर्डिनेट सिस्टम है ओके अर्को कोअर्डिनेट मा पुर्याइन्छ अर्को त्यसलाई चाहिँ हामी बेसिस भन्छ अर्को बेसिसमा पुर्याइन्छ है ओके सो अनि त्यो किन गरिन्छ विल सी दैट इन अ मोमेन्ट है अनि त्यसो गर्नुको त्यसको एउटा त्यसबाट एउटा फाइदा छ I will do that we'll see that take some okay is there any questions so far okay all right so now that's what it does okay so but it's still a linear model it's still a linear model because that the coefficients your coefficients are they never multiply divide each other right okay all right so let's talk let's do it अब हामी चाहिँ mathematically हामी हेर्ने कोसिस गर्यौं हैन so let's do it in code है code मा गरेपछि then it will be probably more easy more clear right let's see about this polynomial projection is useful enough that is it is built into scikit-learn right? We can use this polynomial features your transformer polynomial features transform that is this one right here you देखिरहनु भएको छ नि fn है so यो यसले चाहिँ के गर्छ भन्दा it takes some input and takes it to some other basis another basis right so scikit-learn मा यो पहिले it's ready made है तपाईले manually गर्नु पर्दैन है and यसमा के हुन्छ भन्दाखेरि we do the same thing we have the basic 4 steps right import right import the model right we prepare the data right so you use x so this is our x right x1 x2 x3 x1 is 2 and x2 is 3 and x3 is 4 right okay and then we use poly equal to using we're instantiating here right I'm instantiating also and this was we fit right fit right fit कसरी गरिरहेछौं x लाई फिट गरिरहेछौं है x यो चाहिँ किन गरेको भन्दा we want to be in the feature matrix form है using array लिँदैन हैले it has to be in a n samples by n features right n samples by n features को matrix को रूपमा हुनुपर्छ so that's why we're converting that to a vector मा अनि यो गर्दाखेरि के भयो see this is the result we get okay so let's try to make sense of this okay you exactly के भइराछ understand so हामीले के गर्यौ भन्दाखेरि polynomial features right degree 3 polynomial features degree 3 दियो include bicycle or false है त्यो भनेको के हो त what is that है polynomial features degree 3 okay rather okay let me take a snip of it and then let me try to explain hey what's going on here okay so let me take probably this much right okay all right however look at this of a polynomial so I'm taking basically there is this fn which is this one right here polynomial features fn1 right this is fn okay polynomial features जुन कि यो केसमा हामीले इन्स्टेन्शिएट गरेको चाहिँ यो छ है which is हैन this one okay so यो fn भयो fn मा के छ जस्तो degree 3 है polynomial features को degree 3 चाहिँ include bicycle or false भनेपछि यो कस्तो मोडल हुन्छ भन्दाखेरि तपाईको so this model will be something like this y is equal to हैन so a0 हुँदैन किन a0 भनेको बायस हो है अहिले हामीले हेरेको थियौ नि यसमा a0 है a0 हुँदैन किन a0 is the bias है हैन बायस इन्क्लुड गरेको छैन है यो चाहिँ बायस हो है this one is bias है बायस भन्छ त्यसलाई just like त्यो इनपुट सँग मल्टिप्लाई भएको छ आफैमा हैन त्यो कोएफिसिएन्ट मात्रै छ भने त्यो चाहिँ बायस है बायसलाई हामी इन्क्लुड गरेको छैनौं भनेपछि बायस आउँदैन अनि त्यसपछि के आउँछ भन्दाखेरि यसले चाहिँ अनि के गर्छ भन्दाखेरि a हैन ax a1 भनौं है a1 x को a1x plus a2 x squared plus a3 x cube है यो फर्ममा लिन्छ है भनेपछि के भयो सो हामीले के गर्यौं भन्दाखेरि we did not include bias include गरेनौं है no bias here and त्यसपछि हाम्रो यसको डिग्री कति छ 3 छ है डिग्री 3 Okay, so a1x plus a2x square plus a3x cube यो फर्ममा जान्छ ओके यसको मतलब के भयो भन्दाखेरि नाउ हामीले दिएको चाहिँ यो हो हैन सो हामीले के दिन्छौं यहाँबाट के दिन्छौं x दिन्छौं अनि यहाँबाट के आउँछ भन्दाखेरि यस्तो यस्तो खालको आउँछ है सो भनेपछि हाम्रो कस्तो हुन्छ भन्दाखेरि x चाहिँ कस्तो जस्तै यो केसमा के भयो 2 3 4 हामीले x दियौं अनि पोलिनोमियल यो पोलिनोमियल फिचर्स है यसले चाहिँ के गर्छ fn यो बेसिस फंक्सनले के गर्छ भन्दाखेरि अब यसलाई के फर्ममा लैयो हामीले अब यो कम्पोनेन्ट के रे यो कोअर्डिनेट्सहरु लेख्नु पर्दैन खाली इनपुट मात्र लेख्ने हो भनेपछि के भयो भन्दाखेरि फर्स्टमा x आउँछ x अनि x स्क्वायर अनि x क्यूब हुन्छ है ओके x क्यूब ओके भनेपछि x भनेको के हो 2 3 4 हैन x स्क्वायर के हुन्छ त भन्नुस् त x स्क्वायर के हुन्छ 4 हैन 4 9 16 very good है 2 को स्क्वायर 4 हुन्छ 3 को स्क्वायर 9 भयो 4 को स्क्वायर 16 भयो अनि x क्यूब मा के आउँछ 2 को क्यूब के हुन्छ 8 अनि 3 को क्यूब 7 हो अनि 4 को क्यूब 64 है यो हैन सो यु हेभ अब हामीले इनपुट चाहिँ 2 3 4 दिन्छौं अनि यो पोलिनोमियल बेसिस यो पोलिनोमियल फिचर्स यो बेसिस फंक्सनले के गर्छ भन्दा यसलाई चाहिँ अर्को डाइमेन्सनमा अनि हायर डाइमेन्सनमा पनि लयो यो चाहिँ हरेक पोइन्ट कति थियो 1 डाइमेन्सन थियो अब 3 डाइमेन्सन भयो हैन हेर्नुस् त हरेक पोइन्ट 1 डाइमेन्सन थियो नाउ इज 3 डाइमेन्सन्स है ओके अनि त्यसपछि के भयो भन्दाखेरि नाउ also it took it to a non-linear non-linearity polynomial formula okay so does this match this one the answer is 2 3 4 output yo ta output ho ni ta 2 3 4 2 3 4 right 4 9 16 4 9 16 ani 8 27 64 8 27 64 exact right okay so ठीक छ does it make sense kind of
yes sir
okay all right so now yeah I mean it seems like a lot of math but it is simple math and it is so complicated keeping science right okay all right so okay now we see that the transformer has converted our one-dimensional array to a three-dimensional array by taking the exponent of each value. Hey, isn't that what's going on here? So converted from one-dimensional array, one-dimensional it's a one-dimensional array, okay, but a three-dimensional mother, right? Okay, all right, three-dimensional array, and then taking the exponent of each value. The new higher dimensional data representation can be plugged into a linear regression. Right? Once you let's do something. So let's create a pipeline. Right? We make a pipeline. So where we have polynomial features 7 linear regression. Right? Okay. So you got ahead. Let's see what happens. So what we can do is we make a pipeline. Pipeline makes polynomial features degree 7 and a linear regression. Hey, so let me go back to this one right here, and then maybe I can create a new one. Okay, all right. All right, now let's see. Back. Okay, so here we're making a pipeline. Pipeline okay, so there are two things here in this pipeline. Two things. Okay, so polynomial features degree 7, 7 degree, and this we see linear regression. Linear regression. Right? So and then as you know, this whole thing is what? The whole thing here What is it?
Pipeline.
Pipeline. Hey, very good. Hey, so this is a pipeline. Okay. All right. So okay, we just created a pipeline. Right? Our pipeline बनाएर हामी के गर्छौं भन्दाखेरि now with this transform in place, we can use the linear model to fit much more complicated relationship between x and y. Right? So हामीले के गर्न सक्छौं भने say for example here, हामीले take some, you know, some features. Jस्तै अब यसमा हेरौँ है, यसमा you can see there. Okay, so so we just created this. अब यसमा हामी के गरिरहेका छौं भन्दाखेरि look at this. So RNG equal to we're just creating some random, you know, 50 random numbers. And we're generating 50 random numbers. So I'll just, you know, do this. Okay, so okay, all right. So wait, I have to do all above, right? So okay, so now it's done. Okay, so here you can see here, you understand? So now what we're doing is here we're just creating 50x, right? 50 x बनाएको छौं, right? We're creating 50 I mean actually यो के हुन्छ भन्दा 10 ले multiply किन गरेको होला भन्दाखेरि because rng.ran50 ले चाहिँ 0 देखि 1 को नम्बरको बिचको दिन्छ, which are very small, right? Very सानो हुन्छ नि. So that's why we 10 ले multiply गर्यो भने के हुन्छ भने 0 to 10 हैन, 0 to 1 को रेन्ज भन्छ नि, त्यो त युनिफर्म डिस्ट्रिब्युसन बाट आउँछ. 0 to 10 को बिचको हुन्छ यो र्यान्डम नम्बर्सहरु हैन. So let's say if I say यसलाई निकाल्यो भने हैन, so I mean it's the खालको आउँछ हैन. So which is not, you know, it doesn't serve serve our purpose, right? So अब हामीले त्यसलाई चाहिँ we're going to, you know, 10 गरेपछि यो अलिकति ठुलो नम्बर भयो. So rather than the decimal point bound, so they become bigger numbers from 0 to 10, right? So okay, so which is what you see here, and it's a 0 देखि 10 को बिचमा चाहिँ हाम्रो नम्बर्सहरु हैन. अनि त्यसपछि हामी के गर्छौं भन्दाखेरि now what we do is okay, and y बनाउँछौं है. So this is our x, and then we create y. Y मा के छ? Simply sin x. Y मा के छ? Is simply sin x. Okay, let me take this off. Okay, sin x. You can see the sine curve here. Okay, sine curve. So, okay, तर हामीले यहाँ एउटा यसमा real world data त्यस्तो हुँदैन. Real world data is not like this. It's perfectly ordered, right? So हामीले के गर्छौं भन्दाखेरि so we're introducing some what? यो के होला? What is this? Is it?
Noise.
That's right. Hey, noise. Very good. Hey, it's noise. Hey, I mean noise introduced गर्यो. So we're introducing some noise, right? What त्यो गरेपछि now, yeah, now this is our data. This is our x and y. Right? This is our x and y. Right? So this is the data we're going to train our model on. Right? The yo model, yo pipeline. I mean this material. So the data itself is non-linear. The data is non-linear. Okay. Right? The data is non-linear. Okay. X is one-dimensional. X is one-dimensional. X with the dimension, right? Yes, of course there are 50 points, but each point is one-dimensional. And it's go just your vector form. It's got the column. So X is one-dimensional. Right? X itself, X को हरेक point one. X को हरेक point it's one-dimensional. Okay? One-dimensional. Okay. So अब हामी के गर्छौं भन्दा we send it through this pipeline right here, right? We send it through this pipeline, right? So this is what we're doing. There's the poly model, which is this one. Poly model, just get to you poly model and that, right? यसको नाम के हो? Poly model, right? हाम्रो code मा, right? So this is poly model, right? Okay, so this is polymodel. Your polymodel, we send it through our data. This data we created, the X and Y, right? Feature and label, right? Feature and target. Right? We're sending through our polyfit model. Right? And then now what's going on here? यसमा के भइरहेछ? Step 4, final step भनौं. हाम्रो machine learning final step के हो? हाम्रो 4 वटा 5 वटा step थियो.
Prediction.
Yeah, prediction. That's right. See, we're predicting, right? I mean, your model trained by, and yabar niskadari, I mean, model trained by, right? Trained by. See, now we need to predict. See, if the hisan here, very good, thank you. Okay, so polymodel.predict, and he predict garda here, ke diraso, and so x fit, right? So I'm like ke diraso, x fit is coming from where is x fit? X fit, yeah, it should be somewhere up there, right? X fit, right? So somewhere up there. So X fit, it should be somewhere up there. X, because you know, okay, let's see where it is. X fit can you so yeah, right here. X fit my case 0 to hit 10 could be 1000 watt equal space points or clean space center, right? So X fit when the test data. Okay, that is the test data. Right? Okay, so I'm looking at some we create that. We have already created that test data. So you change के गर्छौं भन्दाखेरि हामी त्यो टेस्ट डेटा दिन्छौं as feature matrix फर्ममा दिनु पर्यो नत्र काम गर्दैन. So so like simply a column np access भनेको चाहिँ यसलाई चाहिँ vector फर्ममा गर्नु मात्रै हो के, right? Okay, all right, so त्यो गरेर now it will give you y fit, and what do? We plot x fit y fit. Your best fit line, best fit feature, best fit for a curve, right? Let's see how it looks. See, I mean, perfect. Understand? So isma एउटा अचम्मको कुरा के भयो भन्दाखेरि अचम्मको कुरा के भयो भन्दाखेरि हाम्रो इनपुट चाहिँ के छ, नन लिनियर छ, तर हामीले के युज गरिरहेका छौं, लिनियर रिग्रेसन युज गरिरहेका छौं. लिनियर रिग्रेसनले यो नन लिनियर डेटालाई कसरी फिट गर्छ, right? Okay, so I mean it's something like magic, right? But non-linear data ma linear model कसरी fit भयो. I mean we see the very good fit, right? Excellent fit, sir. Okay, can you answer that question? Why did it work? Kina work garyo होला? Non-linear, it's a highly non-linear sine function. Sine function is highly non-linear, right? Linearity ko to kunai छैन, right? It's completely non-linear data, sir. We fitted a linear regression, which is just linear. 2-dimensional one, एउटा line हुन्छ, 3-dimensional plane हुन्छ, हैन? So basically non-linearity लाई handle गर्न सक्दैन नि. तर के भयो भन्दाखेरि, but the thing is हामीले त्यो data लाई हामीले linear regression पठाउनु भन्दा अगाडि हामीले के गरिरहेका छौं भन्नुस् त? हामी linear regression पठाउनु भन्दा त्यो data लाई अगाडि हामीले प्री प्रोसेस गरेको छौं. त्यो data लाई हामीले के गरेको छौं? त्यो data लाई के गरिरहेका छौं हेर्नुस् त? What are we doing to the data?
Polynomial convert.
Yeah, and you see that is what polynomial degree 7 मा convert गरेको छौं. अनि त्यो भनेको चाहिँ के हो? यो function के हो? What do we call this function? The pf7 function छ. This is a function, right? So यो function लाई हामी के भन्छौं?
Non-linear function.
What's that? Say that again, please. Yeah,
Non-linear function.
There's a name for it. हामी अघि कुरा B के अरे B a basis function हैन. So this is what basis function. Okay, basis function. यो केसमा polynomial basis function भयो है. Okay, makes sense. Polynomial basis function भयो. Okay, ठिक छ. Okay, so अब अघि हामीले we went into great detail हैन. अब polynomial basis function ले के गर्छ? इनपुट लाई के गर्छ? यसले इनपुट हैन, इनपुट x लिन्छ अनि x लाई के गर्छ? उले हायर डिमेन्सनमा लैजान्छ र पोलिनोमियल फर्ममा लैजान्छ. Isn't that so? Oh, okay. भनेपछि you simply जुन one dimensional x थियो है, one dimensional x लाई उले चाहिँ के दियो, के गर्यो भन्दाखेरि उले चाहिँ त्यो one dimensional x लाई उले 7 डिग्री पोलिनोमियल है, 7 डिग्री पोलिनोमियलमा उले कन्भर्ट गर्छ. भनेपछि हाम्रो यहाँनिर के भयो भन्दाखेरि yes, we are converting or transforming our input to a higher dimension, अर्को डिमेन्सनमा लिएर गयो के है. त्यसले गर्दाखेरि अब यो यहाँ चाहिँ के हुन्छ भन्दाखेरि यहाँबाट निस्किँदाखेरि हैन, इट्स इन अ डिफरेन्ट यहाँबाट जुन निस्किन्छ त्यो यसको pf7 जुन यो फंक्सन छ, यो फंक्सनको आउटपुट चाहिँ lr को इनपुट बन्छ हैन. सो यहाँनिर के हुन्छ भन्दाखेरि नाउ यसको बेसिस नै अर्कै बेसिस हुन्छ, अर्कै बेसिसमा पुगिसक्यो हुन्छ कि हाम्रो x अर्कै बेसिसमा पुग्छ. अनि त्यो बेसिसमा है, त्यो बेसिसमा पुगेपछि हामीले त्यो बेसिसमा हामीले लिनियर रिग्रेसन लगाउँछौँ है. अनि त्यहाँ चाहिँ पर्फेक्ट फिट हुन्छ फेरि है, त्यहाँ पर्फेक्ट फिट हुन्छ. अनि त्यसले गर्दाखेरि अनि हामी ब्याक टु हामी यो बेसिसमा आउँदाखेरि चाहिँ वी हेभ दिस पर्फेक्ट फिट है. सो यो कसरी भयो भन्दाखेरि ओके, लेट मी से इट वन मोर टाइम है. हामीले यदि हामीले हैन त्यसलाई सिम्पली यो pf7 बाट नपठाइकन गरेको भए यसरी यो फिट आउँछ, यस्तो खालको फिट आउँछ आउँदैन. अफ कोर्स है, आउँदैन. देयर इज नो वे, त्यो त हुनै सक्दैन नि. अब यो केसमा त लाइन हुन्छ, लाइनले त यसलाई फिट गर्ने कसै एउटा स्ट्रेट लाइन हुन्छ, स्ट्रेट लाइनले यो डेटालाई फिट गर्ने त चान्सै छैन नि. सो त्यसले गर्दा के गर्नु भन्दाखेरि हामीले यो इनपुट आफैलाई है, x लाई हैन हामीले अर्को कोअर्डिनेटमा लैजान्छौँ, अर्को हाइली मोर कम्प्लेक्स कोअर्डिनेट्स है, हायर डिमेन्सनल मोर कम्प्लेक्स कोअर्डिनेट है, 7 डिग्री है, 7 डिग्रीमा लैजान्छौँ है. अनि त्यहाँ गएर अनि त्यहाँ चाहिँ हामी के त्यहाँ गएपछि के हुन्छ भन्दाखेरि अनि त्यहाँ चाहिँ त्यो लिनियर रिग्रेसन फिट हुन्छ फेरि है, लिनियर रिग्रेसन फिट हुन्छ. अनि हामी ब्याक टु यो बेसिसमा आउँदाखेरि चाहिँ हाम्रो वी गेट दिस नाइस यु नो दैट यो जुन यहाँ हामीले जुन यो कर्भ, यो फिट कर्भ देखिरहेको छौँ नि, विच इज नन लिनियर, तर त्यो जुन 7 डिग्री पोलिनोमियल त्यहाँ चाहिँ स्ट्रेट लाइन नै हुन्छ है, त्यहाँ चाहिँ स्ट्रेट लाइन हुन्छ फेरि है. तर हाम्रो यो बेसिस ट्रान्सफर्मेसन के यो चाहिँ अर्को बेसिसमा जाँदाखेरि त्यहाँ चाहिँ हैन यही डेटा अर्को बेसिसमा जाँदाखेरि के हुन्छ भन्दाखेरि तपाईको त्यहाँ चाहिँ लिनियरली फिट गर्न सकिन्छ है. अनि यो बेसिसमा आउँदाखेरि त्यही चाहिँ के भन्छ नन लिनियर भन्न जान्छ है. ओके, सो द्याट्स हाउ इट वर्क्स. ओके, सो यसमा ओके लेट्स ट्राई समथिङ. जस्तै भनौँ इफ आई ट्राई भनौँ से मैले 1 गरेँ है, पोलिनोमियल फिट 1 गरेँ, लेट्स सी व्हाट ह्यापन्स है. 1 गरेँ ओके मैले ओके. सो त्यो गर्दाखेरि स्ट्रेट लाइन आयो, इट मिन्स के भन्नु देयर इज नो ट्रान्सफर्मेसन बिकज यहाँ पोलिनोमियल डिग्री 1 भनेपछि त त्यसले यसले के ट्रान्सफर्मेसन गर्यो, ट्रान्सफर्मेसन भएन भने चाहिँ यसरी जान्छ. सो इट्स नट अ गुड फिट एट अल हैन. यो त गुड फिट होइन है, यो हैन, नट अ गुड फिट एट अल. किनभने वी ट्राइङ टु यु नो फिट अ स्ट्रेट लाइन लिनियर हैन थ्रु नन लिनियर डेटा. अब यसै गरी मैले अब यहाँ यसलाई डिग्री 2 मा लैजाउँ है, डिग्री 2 मा लैजाउँ. इफ आई डु दैट लेट्स सी अब कर्भ आयो अलिकति हो भयो हैन. लेट्स ट्राई डिग्री 3 है, डिग्री 3 है. सो लेट्स रन दिस. ओके अलिकति इट्स गेटिङ बेटर हैन. लेट्स ट्राई डिग्री 5 है, डिग्री 5 ट्राई गरौँ. See, I mean it's getting better, right? Okay. About degree 7 which you saw, it's working fine. 7 was एकदम राम्रो छ है सो यसरी हामीले यो यो गर्दै जाने very good fit है how about degree say 13 है अब हामीले डिग्री बढायो भने अब चाहिँ के हुन्छ डिग्री 13 गर्दाखेरि के भइरहेछ भन्नुस् त के हुन्छ होला ठिक छ यो ठिक छ के is there a problem छ कि ठिकै छ जस्तो छ डिग्री 13 गर्दाखेरि के लाग्छ तपाईहरुलाई so is it approximating the sine function well
Overfit भयो जस्तो लाग्छ
yeah overfit very good overfit भइरहेछ हेर्नुस् त see it's kind of following the noise right? It's following the noise हैन actually हाम्रो sine त nicely यसरी जानुपर्ने नि see यो फ्ल्याट किन भयो भन्दाखेरि यो नोइजले गर्दा यो डेटा तल आएको छ अनि त्यसलाई फलो गरिरहेछ कि so clearly it's overfitting see यसलाई अझै बढायो भने के हुन्छ अझै overfit हुन्छ because हाम्रो मोडल कम्प्लेक्स more and more complex भयो नि त जस्तै 25 राखौं है so if I do 25 है serious overfit हेर्नुस् हैन it's खतमै छ है 25 मा त खतमै हुन्छ है so okay very good so हाम्रो 7 looks like it's working the best right all right very good all right so our linear model okay how much time we got okay 1 minute so let me stop here okay and then end so please join